Hi everyone. So today we will discuss Doppler effect in case of sound wave. Before discussing the Doppler effect, first we understand how a sound wave is received by an observer which was emitted by a source. So there are three processes. Source emits a sound wave in form of pulses. It propagates through a medium and at the observer's ear it is received. So three steps are involved: emission, propagation and reception. Now come to emission point. At the emission point or at the source, the sound wave emitted has three parameters which characterize it. First is n, second is lambda, third is v. What is n? N is emission frequency. What is emission frequency? Emission frequency means number of pulse generated per second. So it is a source property, means frequency is decided by source. It will decide how many pulse it will generate in the medium. Now come to V. This V is nothing but velocity of propagation. So velocity of propagation depends upon the medium. In which medium the sound wave is generated or propagated. The velocity of propagation is V. Now come to lambda. Lambda is what? It is very essential to understand lambda before discussing the Doppler effect. So we will understand the concept of lambda, not only the formula. What is meaning of lambda? You see, the wave has a velocity of propagation v. It means what? In 1 second, the wave will travel a length of v meter. Correct? A v meter length it will propagate. Now come to emission frequency, n. Number of pulses generated per second. It means what? In 1 second, n pulses are generated and they are spreaded over a length of v. It means what? N pulses will be spreaded over this length. Correct? Lambda is what? Lambda is the distance between two consecutive pulses. Nearby pulses. Correct? This distance is known as lambda. So this we can very easily calculate. Total length is v. Total number of pulses are n. It means this distance lambda, this is nothing but total length by total number of pulses. That is a formula you know by v is equal to n lambda. But here in Doppler effect, this concept is essential to understand. Correct? If this you have understand, ki n is source dependent, v is medium dependent, and lambda is both source and medium dependent, then we can move on Doppler effect. So let us see Doppler effect, what Doppler effect tells us. The Doppler effect tells if there is a relative motion between source and observer, means either source is moving towards observer or source is moving away from the observer, or observer is moving towards the source or observer is moving away from the source. In all that cases, what frequency emitted by the source, the same frequency will not perceived by the observer. It will perceive some different frequency. This is what Doppler told. So he very well calculated and introduced the formula how we'll calculate the effective frequency as perceived by the observer. So let us see various cases and try to understand what Doppler told about this shifted frequency. Now case first. Suppose source is moving towards observer with velocity vs. In that case, what the parameter will affected of the emitted wave, that is lambda. Lambda will be affected. We can write like this, lambda affected. How lambda affected? Let us see. If source is stationary, it is not moving, I have already told, n pulses will spread over a length of v. But if source is also going forward towards the observer, in that case, the length available for spreading of n pulses emitted by the source will v minus vs, not v. Means length will be reduced. In that case, what is the effective wavelength? Effective wavelength will be lambda dash will be what? V minus vs divided by n. That is the effective wavelength of the wave propagating. Means actually the wavelength of the wave is distorted due to motion of the source. Now velocity of propagation is v. Velocity of propagation is v. It is medium dependent. Correct? Then what is the effective frequency n dash is equal to v by lambda dash. Lambda dash has been changed due to motion of the source. Now if you put here, what you will get? You will get v by lambda dash, v minus vs divided by n, and that is equal to nv divided by v minus vs, where v is the sound velocity and vs is the source velocity. So this is the effective frequency change when source moves towards the observer. In opposite case, when source move away from the observer, for n pulses to spread, it will get more length, like v plus vs. So the effective frequency will be n dash is equal to nv by v plus vs. Similar fashion. So first case mein we will get minus sign here. In the second case, when source is moving away from the observer, we can get plus sign here. Or combinedly we can write down n dash is equal to nv divided by v plus minus vs. This is the formula when source move towards the observer or away from the observer. Plus sign indicates away from observer, away from O, or minus sign represents towards O. So key point we have to remember, when source moves, wavelength distorts. Due to wavelength distortion, frequency is changed, and that frequency is nv by v plus minus vs, where v is the sound velocity, vs is the source velocity. And sign convention. Plus means away from the observer, minus means towards the observer. Now discuss the second case. Now come to case 2. Here observer is moving towards source with a velocity of VO. Now you see, once the wave is emitted from the source, velocity of the wave in the medium is v. So it will reach the source ear by velocity of v. But once source is moving towards, it will catch the sound wave earlier than what we expect with the velocity v. Means here there is a illusion to the observer. It's an illusion itself. Velocity of wave is not changing. It is moving with v velocity only. But observer will feel it is catching the wave much earlier than what was expected by the velocity v. Means velocity is affected. Due to motion of the observer, the factor affected here is velocity. That v dash we can write down. What v dash will be? V, absolute velocity of the wave, plus VO. Means observer's velocity will add here. That much enhance of velocity, the observer have illusion when receiving the sound. Means here velocity is changed. But here lambda will not change. Once source is not moving, lambda will be same. So a new frequency, what it will observe here? N dash is equal to what? V dash by lambda. Lambda will not change, correct? So V dash, what V dash will be? V plus VO divided by lambda की value होगी V by N, and that must be equal to N V plus VO divided by V. So this is the formula for the effective frequency as the observer perceives is NV plus VO by V when the observer moves towards the source. Similar way, if observer moves away from the source, the effective velocity will be reduced by what amount? V minus VO. Means velocity will reduce by VO factor, that is the velocity of the observer. Then N dash will be equal to N V minus VO divided by V. If you combine both, you will get N dash is equal to N V plus minus VO divided by V. This is the effective frequency what you will get when the observer is moving towards or away from the source. And what is the sign convention? If it is plus, means moving towards source, moving towards source. And if it is minus sign, means moving away from source. Away from source. So this is the second case where due to shift in velocity, the frequency is changed. In first case, due to shift in wavelength, the frequency is changed. So what is the conclusion? If source moves, lambda is affected. And that is actually affected. Waves are actually compressed. But if observer moves, the velocity changed. But this is illusion for observer. Actually, the wave is moving with the absolute velocity v, but observer perceives that velocity has increased or decreased as per the case.